In this episode, I'm going to talk to you in a bit more depth about the Clostridia family of bacteria. The reason this is an important conversation to have is Clostridia species have been implicated in autism, and we have the means to test for certain Clostridia species with the organic acids test that I've spoken to you about before, and we'll continue talking to you about this test, the organic acids test, because it's so important and so valuable to run for your child. Now, there was an important study in the early 2000s that found that autistic children not only had more Clostridia species than their peers in the study, but they also had higher numbers of those species. So there's about 100 or so Clostridia bacteria species that we have identified so far. Most of them are not really harmful. They're beneficial, or at least not harmful as far as we know. But a few of these Clostridia species are harmful. You may have even heard of some of them. Clostridium difficile is the most infamous one. And then a few other harmful ones are Clostridium tetani, Clostridium perfringens, and Clostridium botulinum. And what's the problem with Clostridia? So many of the Clostridia species are resistant to a lot of antibiotics that we have, especially commonly used ones to treat ear infections, for example. So in part, this is because some of these Clostridia species are spore forming. So spores are basically like the eggs that they kind of lay, and the antibiotic may kill the bacteria, but it does not act on the spores. So they are left behind, and they allow to kind of the infection to persist even after antibiotics. So this is why Clostridium difficile in hospitals is such a, it kills tens of thousands of people, because they use antibiotics in hospitals and things like that, but the Clostridium species are resistant to that because of the spores. So people are very susceptible in those instances to kind of these antibiotic resistant bacteria. The other problem with the spores is that they are also resistant to heat, and they can survive our stomach acid, other defense mechanisms. So it really leaves us in a tough spot when, if you give a young child antibiotics, let's say for an ear infection, then you kill off all the bad bacteria, you kill off all the beneficial protective bacteria, and you leave behind harmful Clostridia. And this really leaves them vulnerable to Clostridia overgrowth. And this has been found in many autistic children. This is why it's so important for me to talk to you about Clostridia. So the Clostridia family of bacteria are highly metabolically active. They can ferment carbohydrates and even some of the amino acids that we eat. So the amino acids are building blocks of protein, and Clostridia species can take them and basically they eat them in a sense, and they create a range of compounds that can be toxic to the gut, brain, and nervous system. And one of those is propionate, which is a short-chain fatty acid that's also been implicated in autism. And there's a couple of other ones that I want to talk to you about. Now, this is a little bit more technical than most episodes, but it is important, and you'll see in a couple of minutes why. So the first metabolite that Clostridia produce is called 4-cresol, or also known as p-cresol. And the reason it's important for you to be aware of this is because the organic acids test for this, right? So one of the main mechanisms this compound damages health is it basically, when the Clostridia species take the amino acid tyrosine, ferment it into this 4-cresol, it can get through the gut into the central nervous system, and there it can bind with an enzyme called dopamine beta hydroxylase, DBH, which converts the neurotransmitter dopamine to noradrenaline, or if you're in the USA, norepinephrine. So 4-cresol gets stuck in the DBH enzyme, thus it prevents dopamine from getting converted into noradrenaline. What happens next? Well, we have buildup of dopamine in the central nervous system and the brain. Now, the problem with this reaction of the inactivation of the enzyme is it's irreversible, because the 4-cresol gets jammed into the enzyme and it cannot get unstuck. So it's rendered permanently inactive. Now, we have a buildup of dopamine, and not enough norepinephrine is being, or noradrenaline is being produced in the central nervous system. This causes neurotransmitter imbalances. And as you can imagine, that's not going to affect behavior very well. Now, dopamine is also a very reactive molecule, so the more of it builds up in the central nervous system, the more it has a chance to kind of damage nerve cells, brain cells, to deplete antioxidants, and just cause, basically wreak havoc in there. So certainly not a desirable scenario. Now, this is why testing for this compound on the organic acids test is so useful, because the more of it that is produced, that can be detected in your child's urine, the it's associated with a higher amount or higher numbers of Clostridium difficile bacteria. And the nice thing about knowing that is we know what to do about Clostridium difficile infection. So there are certain antibiotics that still work on them, there's certain herbs, and there's certain probiotics that you can give to your child in order to reduce those Clostridia numbers. So this is why it's so important that I'm bringing this to your attention. Now, another compound is called HPHPA, which is the short name for the chemical, but it is produced by Clostridium botulinum, sporogenes, and calorie tolerance. Sorry, it's difficult. But what's important to know about this chemical is that it also can inhibit that enzyme I was talking about, dopamine beta hydroxylase. So it can also cause neurotransmitter imbalances in the brain, which of course it's easy to deduce that that will cause behavioral changes, right? So this is another chemical that the organic acids test for. This is why I felt it's so important for you to know, and I talk about these two, for cresol and HPHPA, in my book as well, because it's super important. So this is just a quick primer on Clostridia. In future episodes, we'll talk about what to do about when those numbers are high on the organic acids test, and what actions you can take. So thank you for listening, and I hope to see you on the next episode.